recording. There we go. All right, so we're starting with some questions from the homework. This is the 7.3 worksheet, and somebody was asking about 3b. Okay, so there's the question for 3b. This is an X, by the way. Sorry for the terrible penmanship here. My word. There we go. Okay, so step one is we have to try to find a way to make the bases equivalent. So 4/7 to the 5x is equal to 64 is 4 cubed. 343 is 7 cubed. Now, there is a rule in that you learned in grade 9 called power of a quotient rule, which says that if you have the quotient x over y to some a, you can distribute that exponent like so. So that means that you can go backwards, which means that I can take this and now rewrite it like so. And I'll bet that's the part that you didn't get, person who asked this question. Now that I have this base to that power and this base to that power, I can say, therefore, I can make the equation 5x is equal to 3 times 2x minus 1. And does everybody get why it's a times, right? Because when you take the power of a power, the exponent of an exponent, you multiply them together. Again, you learned that in grade 9. So 5x is equal to 6x minus 3, which means that negative x is equal to negative 3, which means that x is equal to 3. And you can do a check if you want to. By all means, you could, if you were allowed a calculator. Obviously, on this test, you're probably not going to be allowed a calculator. But if you have access to a calculator, 4/7 to the, what's 5 times 3? To the 15 should equal the exact same thing in your calculator as, what was it? 64 over 343 to the power of, so that'd be 2 times 3, 6 minus 1 is 5. So there you go. Punch those two things in your calculator. They should exactly be the same thing. So let's see. So let's go clear, 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 clear. Oh, wait, are we even on? Are we on? Clear. There we go. So open a bracket, 4 divided by 7, close bracket, to the power of 15. It's 0.000226, blah, 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 blah. And open a bracket, 64 divided by 343, close bracket, to the power of 5. Identical. We did this right. There you go. Okay. 3C. Okay, I'll still do the 4C you're asking about, but let's do 3C. Let's look at 3C. Now that you've seen me do that, how about we just give you a hint? All right. What's the hint? Actually, I don't know how to do 3C. Let's see. Well, obviously, I would like to get the two bases to be the same. Okay, you know what? I'm going to give you, I'll just give you a hint for 3C. Tell you what, here's the hint. Hang on, let me just clear some space. For 3C, what you can do is you can say, well, I'd like this to be, and I'd like this to be, okay, hang on, let me just finish copying it, 2x minus 1. How about, my hint is, don't think of this as a fraction. See, on this one I had to get 4/7 and I had to turn this into 4/7. But on this one, how about I turn these both into 3 to the power of something? Because notice, unlike 4 and 7, which would take a heck of a lot of irrational exponents to turn a 4 into a 7, to turn the base of 4 into the base of 7, 3 is the common smaller base of 9 and 27, right? Because 3 squared is 9, and 27 is 3 cubed. So I can simplify these two things into just basic powers of 3, given a little bit of elbow grease. Your generation has not yet embraced that expression. It means with a little bit of work. Okay. So is that enough of a hint, Lucas? Oh, sorry, I said a name, rats. Is that enough of a hint? Oh, anonymous student? Okay. All right, 4C. Can I give you just a hint on this one? Okay, let's check out 4C. 4C. Let me make some room again. Oh, anonymous student who asked about 3C. If you try it again and you still can't get it, let me know, and we could go through it again. All right, we have 1/5 to the power of x minus 3 minus 4 is equal to negative 3. So this thing here has to be 1, right? 1 minus 4 is negative 3. So why don't I just say that this has to equal 1? And now from there, what do you know about anything to the power, or what's the rule? A number to what power is equal to 1? So person who asked that question, what goes, that's a blank. Pretend that's a blank. Blank, blank. What goes in that blank? Person who asked the question for 4C? You should know this. I bet you do. No? Person. Oh, somebody could help that person out. What goes in that blank? What turns any base into 1? Correct. So that means my new equation is x minus 3 equals 0. Right? Person who asked that question, let me know if the logic of that makes sense to you. All right, that's all the questions I'm taking on this one. Time for you to do stuff. Can you please take out the ACC booklet that I gave you? It says ACCs from May to June. I even gave it a beautiful title page. Look at the work I put into that title page. And let's do them both. We'll give you a few minutes. I know you're saying, but you said you wouldn't test us on this. Okay, then fine. You can use your notes from the lesson we did. But once you're done this one, put your notes away and put your calculator away and see if you can do those two equations. And ooh, look at this. This one's going to use that hint that I gave the person who shall be unnamed on the question 3C. Okay, so let's see. How many marks is this? 3, 4.5, 6.5, 7.5, 9.5, 12.5. So if we give you 15 minutes, that should be lots of time. And that gives me enough time to do attendance and take care of some stuff. Now, for people at home, boy, that's going to be quite the video if I just sit here with dead air for 15 minutes. Would you like some thinking music while you work? I'll give you some thinking music while you work. Here we go. Can you hear that? There we go. I better. You know what? I better not. That's going to get me a copyright violation when I post this. Okay, so let's see. There we go. I will pause the video then, and again, I'm going to give people about 14 minutes now to try these two ACCs, and then we're going to go over them. So guys at home, pause the video now. Okay, we're back. Here we go. Graph the following exponential function. Okay, so I'm going to have to move this up so I can see, and I'll write it over here. There. So that's what I'm graphing. And okay, so my parent function for this, it's always nice when you're doing transformation style graphing to have your parent function kind of handy. There we go. So y equals 3 to the power of x. So what does that look like? Well, y equals 3 to the power of x goes through 0, 1, because 3 to the power of 0 is 1. And then 1 becomes 3, right? When x is 1, y is 3. And when x is 2, y is 9. You know, I might even, just for fun, if you didn't do this, don't worry about it. I might even count by ones this way. 1, just so I can see the curve better. 2, and 3. Yeah, I like that. So that's going to be 1, 2, 3. So when x is 1, y is 1, 2, 3. When x is 2, y is 1, 2, 3, 4, 5, 6, 7, 8, 9. Just enough room to make that happen. And then, of course, when x is negative 1, I get a third. That's supposed to be a third. And at negative 2, I get a ninth. And at that point, you can see that we are hitting the point where the distance between our graph and the x-axis is too small for the big fat pen to deal with. Okay, so there's the graph. That would give you how many marks just for the graph? Label 3 points. Okay, so label 3 points. Labeled, there's always an argument. Did I just label it? No, I've indicated them. I haven't labeled it yet. So this is, of course, the point. What is that? That is 1, 3. This is 2, 9. And this is 0, 1. And this one here is negative 1, comma 1/3. There we go. There's 4 points. I only had to do 3. I should get a bonus mark. Okay, so there we go. Oh, so that was only, oh, they're only a half mark each. So there, I just got my 3 half marks by labeling points. I got the 3 marks for the graph. I'm going in the right direction. Everything's good. Now, domain and range. This is the easiest of the marks here. Obviously, the domain is x can be any real number. If you like interval notation better, you can say 0, or no. You can say negative infinity to infinity. The range is, of course, y has to be greater than or equal to 0. Oh, sorry. Whoa, that would have cost me half a mark. Greater than 0, right? You can't touch 0. And, oh, wait a minute. That's, oh, duh. What am I doing? I graphed the parent function, forgetting that that's only the parent function. My God. Okay. As if it's going to be that easy. Oh, we're not going to do that. We're not going to do that. There we go. Okay, sorry. That's the parent function. I should even, you know what I should do? I should even make that a dotted line. I'm going to make it a dotted line. Here's how you make things a dotted line. Okay, sorry. I need more caffeine, clearly. Much better now. Okay, what am I doing to this thing? I'm going to write it in words. I am multiplying y values by 2. I am reflecting in the y-axis, and then I am shifting down 9 units. So that's what we're doing. So we're multiplying our y values by 2. So let's see. So let's take this guy right here. Let's first, you know what? Actually, I think I might do the reflection first. So I'm going to reflect on the y-axis. Done. Then I'm going to multiply by 2. So 1 times 2 just jumps that point to 2, but then it shifts down 9. So that's going to move it to negative 7. So negative 1, 2, 3, 4, 5, 6, 7. Boom, there it is. Let's take this point, which was 1, 3. Let's reflect it in the y-axis. So now it's over here. Then we're going to multiply the y values by 2. 3 becomes 4, 5, 6. Now the point is there. And then it shifts down 9. So it's at 6. It goes down 9, which takes it to negative 1, negative 2, negative 3. Okay? While I'm at it, why don't I, let's see, hang on a sec. Did I do this right? 9 from here. Negative 1, 2, 3, 4, 5, 6, 7. Yeah, that's good. Okay, while I'm at it, you know, this negative 9 is my horizontal asymptote because there's absolutely no way 3 to the power of negative anything or 3 to the power of anything can be 0. So if this can't be 0, 2 times 0 is 0. This y can't be negative 9. So this was 1, 2, 3, 4, 5, 6, 7, 8. There we go. Why don't I put the horizontal asymptote down? There we go. Okay, so I've got 2 dots. Let's get another dot. Let's take a fancy dot. Let's take this dot. So we've already done this dot, and I could label them after. And of course, if you're having a hard time counting, remember I did tell you that by all means, you could go through the steps here and just do mapping notation. So the point 0, 1 reflects in the y-axis, which didn't change it. The y values got multiplied by 2, making it 0, 2, and then it got shifted down by 9, making it 0, -7, which is that point right there, 0, -7. And then the next point I did was the point 1, 3, which when I reflected in the y-axis means that it became -1, 3. And then when I multiplied the y values by 2, I got -1, 6. And then when I moved it down 9, I got -1, 6 minus 9 is -3. And there we go. Okay, so you can do it that way if you like. Okay, let's do this one now. In fact, I'll do that one that way. So let's see, that is the point when x is -1, y is positive 1/3. Okay, so let's see. First we reflect in the y-axis, which means this thing jumps over to become positive, right? Because that -1 now makes it over there. And then we multiply the y values by 2, making that 1/3 become 2/3. And then we shift down 9, so 2/3 minus 9 becomes -8 1/3, right? So that's going to be 1 over and -8, which is here, and 1/3, so maybe there. And so there we go. Looks pretty good from here. So it's going to look something like this. There we go. Something like that. You know, one thing that you could find on here, if you really wanted to, is you could find, I didn't bother, here, a little bit, let me make that, get that out. What if I actually wanted the x-axis, or the x-intercept? You could solve that very nicely, right? You'd have to go, okay, -9 moves over to the other side of the equation, becomes 9. And then 9 divided by 2 equals 3 to the -x. And then, okay, so what's 9 divided by 2? Well, that's 4.5, right? And then 3 to negative some power is 4.5. So what is that power? Let's say 3 to what power is 4.5? Now, when I square root 3, well, sorry, if I take 3 to the power of 1, I get 3. 3 to the power of 2 is 9. So it's somewhere between 1 and 2. So I could guess and check. 3 to the power of 1.5. Oh, that's too big. That's 5. How about 3 to the power of 1.25? Ooh, that's too small. How about 3 to the power of 1.4? Oh, that's pretty close. So I'm going to say that roughly that's around 1.4. So -x is equal to about 1.4, which means that x is around -1.4. So there we go. There's another point. I could say that at around -1, and that's 0.5, so I don't know, about there. There we go. Do you have to do that? No, but it's pretty easy to do. Now you might be thinking, ugh, do I really have to guess and check if I want to solve something like this? Well, starting with our lesson tomorrow, the answer is no. There'll be a better way. I'm like Ron Popeil selling you stuff. There must be a better way. There is. It's called logarithms, but you don't know how to do that yet. So there we go. There's our perfect graph. I can label some points. I can use the labels that I found here. This was, what was this? This was negative, no, what was this? This was +1. So this was 1,8 negative, oh man, jeez. -8 1/3. That was this dot. This dot, what was this dot again? This dot was 0, -7. And what was that dot again? That dot was -1, -3. There's my 3 half marks for labeled points. I'd get 3 marks for having the graph right. So 3 marks for the graph, 3 marks for labeling the points, and then the domain and range. Okay, now let's do domain and range, now that we've got the right thing. So the domain on this thing is we go from -infinity to infinity, or you could just say x is an element of reals. But the range, now the range is that y is greater than, but certainly not equal to, -9, because you can't get that value. If you put that into interval notation, you'd say you'd start with a curved bracket at -9, and you go up to infinity. And the equation of the asymptote is, again, y equals negative 9. So there you go. We are not going to put one of those on the test this time, but now you know how to do it. All right, 7.3. Let's solve some equations. 4 is 2 squared. 8 is 2 cubed. Now the bases are the same, so I can say, therefore, 2 times 2x equals 3 times 2x minus 3. So that's 4x is equal to 6x minus 9. Negative 2x equals negative 9. X equals 9 halves. I don't want decimals. That's my answer. I'm happy with that. You can do a check if you want. All right, B. I'm going to change this into 1/9 is 3 to the negative 2. And on this side, I have 3 times 3 cubed to the x plus 3. There. My bases are all 3's. So now, on this side of the equation, let's make this one power. So you take the power of a power, and that's negative 2x. And if I make this one power, you know what? Now that I think about it, I think I might actually put a line between here and here. This is a lot of thinking in my head. Why don't I simplify this first? Power of a power, that's negative 2x. And here, remember this is 3 to the 1. And when you multiply powers that have the same base, you add their exponents. But these two exponents, of course, are getting multiplied. So there. Now I'll make my equation. Therefore, negative 2x is equal to 1 plus 3 times x plus 3. So that's going to be negative 2x is equal to 1 plus 3x plus 9. Move the 3x to the other side. Negative 5x is equal to 10. So x is equal to negative 2. And you could run that through a calculator and do a check if you want. Actually, you don't even need a calculator. You could do that one mentally. 1/9 to the negative 2 is 81, right? Because you take the reciprocal. Oh, I said reciprocal, then I didn't do it. That's 9 over 1 to the positive 2, which is 81. So that's the left-hand side. And the right-hand side is 3 times 27 to the negative 2 plus 3. And that's 3 times 27 to the power of 1. And 3 times 27 is 81. So that's true. Any questions on how I did that? So like I said, this ACC is just for your edification only. We're not testing you on it. But these for sure guarantee you some questions like that on the next test. Any questions? Concerns? All right, let's move on to the activity you were supposed to do yesterday when Mr. Favreau was here. You were supposed to do this 8.1 activity. And here's the answers you were supposed to get. Now, where did I put them? I had them here some places. There we go. You were supposed to get here that x equals 2. You were supposed to get here that x equals 0. You were supposed to get here that x is